Welcome to the debate. Imagine you are running a global logistics empire. You have this massive fleet of cargo ships halfway across the ocean.
Sounds lucrative.
Well, it would be, but there's a major catch here. First, every single one of your competitors can see exactly what is inside your containers. They know who you are shipping them to and exactly what you are charging.
Okay, yeah, that's not ideal.
Right? And second, the price of the shipping fuel fluctuates wildly while the ship is literally already in transit. So by the time your cargo actually reaches the port, the fuel might cost 5 times what you originally budgeted.
I mean, that sounds like a fast track to bankruptcy. You're entirely at the mercy of unpredictable global conditions and, well, you're completely stripped of any commercial confidentiality.
Exactly.
But, as we both know, that is exactly the reality for enterprises trying to run business-to-business stablecoin payments on public blockchains today.
Spot on. And that really brings us to the core tension we are unpacking today. We are looking at a fundamental shift in how digital dollars move. Specifically, does integrating Utexo's Bitcoin-native stablecoin infrastructure provide a necessary, pragmatic leap in enterprise value?
Or, on the flip side, does shifting to their model of off-chain client-side validation, just does it introduce way too much operational risk and architectural complexity?
Right. And this isn't just a theoretical exercise anymore either. This discussion is being forced by some very real industry movement.
Yes, specifically, we are looking at Utexo's recent integration into Tether's wallet development kit. The WDK, as it's often called, and that's alongside Utexo closing a $7.5 million seed funding round, which Tether itself actually led.
Which is massive. So I'll state my position clearly. When I look at what Utexo is building, I see a structurally superior, absolutely necessary evolution for enterprise settlement. It takes on the classic trilemma of blockchain payments, gas fees, commercial privacy, and speed, and it actually solves it.
Right.
It gives enterprises deterministic fixed costs completely denominated in USDT.
Right. And coming from an exchange operator's perspective, I look at that exact same infrastructure and I see an incredibly elegant theory that honestly might hit a brick wall in practice.
A brick wall?
Yeah. The technical complexity required to make this work, particularly the persistence risks associated with the RGB protocol's off-chain state, presents massive integration hurdles. I mean, we are talking about upending how wallets have fundamentally functioned for the last 10 years.
Okay, well, let's start by looking at why we even need to upend the current architecture in the first place. Because to understand the value of UTXO, we have to look honestly at how account-based blockchains operate right now.
Sure.
Networks utilizing the Ethereum Virtual Machine, or EVM, as well as networks like Tron, they are fundamentally broken for enterprise B2B payments.
Okay, broken is a strong word. I mean, they process billions of dollars daily.
They process it, yeah, but at what operational cost? These networks force enterprises into completely unpredictable gas fee volatility. Because they use a global state machine, every single participant is sharing the exact same computational resources.
Right.
So if there's a massive new NFT collection minting or a sudden spike in decentralized exchange trading, the network just gets congested. You are suddenly caught in a global fee auction just to move your corporate treasury.
Which is a pain point. Absolutely.
You literally cannot forecast your unit economics when your transaction fees are dictated by someone else's trading frenzy on the other side of the world.
Okay, the fee volatility is undeniably awful for accounting. But the transparency? That is often touted as a feature of public ledgers, not a bug.
A feature for auditors, perhaps, but a total nightmare for business operators. I mean, these networks broadcast highly sensitive commercial data on a globally observable ledger. Every vendor you pay, every payroll distribution, every arbitrage trade you execute, it's all visible to analytics firms and your direct competitors.
Yeah, it's a fair point.
Utexo fixes this by unifying 3 distinct technologies. It uses the Bitcoin base layer for ultimate security. It uses the Lightning Network to achieve instant 200 millisecond finality. And it uses the RGB protocol to ensure commercial privacy. And then, It abstracts that massive technical stack into a single SDK.
And see, that is exactly where my pragmatism kicks in. Utexo is promising to abstract the complexity of Bitcoin, Lightning, and RGB into a clean little SDK. But enterprise infrastructure demands absolute battle-tested reliability.
Which Utexo provides.
Well, let's look at how Utexo is actually achieving those fixed deterministic costs you mentioned earlier to shield a business from the absolute nightmare of Lightning channel management, which, remember, requires opening payment channels, balancing liquidity, running constant watchtowers.
Right, it's heavy lifting.
Heavy lifting is an understatement. So to avoid that, Utexo acts as a state channel layer. They're pooling the liquidity and handling the routing automatically on the back end.
Exactly. That's how you get the seamless developer experience.
Right, but aren't we just trading one problem for another? By completely abstracting channel management away from the enterprise, you are replacing decentralized network congestion with a direct reliance on Utexo's proprietary liquidity routing.
I wouldn't call it proprietary reliance.
If my exchange depends entirely on Utexo servers to maintain fixed costs and route my payments successfully, that introduces a massive centralization vector. You are trading algorithmic fee volatility for counterparty routing reliance.
Okay, I see why you think that, but let's break down how the mechanics actually work under the hood. Because Utexo is not acting like a traditional financial counterparty here. Yes, Utexo pools liquidity. Yes, they optimize the routing. But the actual execution over the Lightning Network is still cryptographically anchored to Bitcoin's base layer via smart contracts.
Still relies on their uptime, though.
But Utexo cannot freeze your funds. They cannot steal your USDT. The setup is inherently non-custodial.
Non-custodial doesn't mean perfectly reliable, though. If their routing engine goes down, my payments fail.
But compare that routing reliance to the alternative that enterprises are using right now. To avoid gas fees on main networks, companies are relying on cross-chain bridges. They wrap their stablecoins, they send them across highly vulnerable smart contracts to cheaper side chains.
The bridges are definitely a weak point.
They're huge honeypots. They rely on multi-signature federations holding massive pools of locked value. When a bridge gets hacked, and we have seen, billions of dollars drained from them in recent years?
Sadly, yes.
Your money is gone permanently. With Utexo, it allows a native asset transfer. There is no wrapped asset, there is no bridge. The Lightning execution anchors directly to Bitcoin's unspent transaction output model.
Okay, let's pause right there. I will absolutely grant that anchoring to Bitcoin's unspent transaction output, the UTXO model, is the most robust security foundation in crypto, treating digital assets like physical cash, where each output is a unique cryptographic coin. It's brilliant.
Thank you.
And yes, it is certainly safer than a honeypot bridge, but the real friction in Utexo's model isn't just in the payment routing. The friction is in the data itself. We really need to talk about the RGB protocol and this concept of client-side validation.
Oh, let's dive into it. Because client-side validation is exactly how we solve the privacy issue, which goes back to that logistics analogy. We want to hide the cargo.
Right. But let me explain why hiding the cargo comes at a terrifying architectural cost. You are highlighting the benefits of RGB, but we need to explain how it fundamentally upends the way wallets work.
It changes the paradigm, sure.
Standard EVM wallets are essentially stateless. If I open a standard wallet, the software manages my private key, it signs a transaction, and it broadcasts it to the network. That's it. The blockchain remembers everything else. The blockchain acts like a giant public whiteboard, and my wallet just checks the whiteboard to see my balance.
Which means everyone else can check the whiteboard to see your balance too.
Exactly. So RGB changes the paradigm. Instead of using a public whiteboard, RGB uses client-side validation. This means the actual validation data, the cryptographic proof of that stablecoin's entire history, is not on the blockchain.
It's private.
It is stored off-chain, locally on the user's device or the enterprise's server. When I send you a payment, I am literally handing you a sealed cryptographic envelope with the receipts, and we only record a tiny encrypted hash on the Bitcoin network to prove we made a trade.
Which completely prevents front running, it protects business intelligence,
And frankly, it's an absolute prerequisite for true institutional adoption.
But think about the burden that places on the wallet. RGB requires the wallet software to actually store and manage that continuous cryptographic proof data. If that data is lost, if the hard drive fails, if the cloud backup is corrupted, or if the wallet just mismanages the local state, that asset is hopelessly compromised.
Well, the Bitcoin UTXO might still be sitting there on the blockchain, perfectly safe. But without the off-chain RGB proof data to verify what that UTXO represents, the USDT stablecoin is functionally gone. You cannot spend it. That is a terrifying proposition for an enterprise wallet provider who is used to just querying a node for a balance. Okay, that used to be a terrifying proposition. But this is exactly why the recent source material we are discussing, specifically the integration into Tether's wallet development kit, is so critical. It proves that the specific engineering solutions for this exact data risk have already shipped.
I'm listening, but I really need to hear how you solve a completely deleted hard drive.
Utexo built a dedicated adapter layer called the WDK-Wallet GRBG module. This isn't just some theoretical workaround. It directly translates these complex, stateful RGB operations into the familiar abstractions that wallet developers are already used to. Specifically, this module derives the RGB keys and the validation state directly from standard BIP39 seed phrases.
Wait, you mean the standard 12 or 24 word recovery phrase that every crypto user writes down on a piece of paper?
Exactly that. For the last decade, the absolute industry standard for backing up a wallet has been that 12-word seed phrase. The Utexo adapter derives the necessary RGB off-chain data from that exact same seed.
Interesting.
It also allows the off-chain validation proofs to be backed up and restored in an encrypted format alongside normal wallet data completely automatically behind the scenes. So if your server burns down, you input the 12-word seed phrase, the adapter pulls the encrypted backup, derives the keys, and your stablecoin is recovered. Doesn't that directly neutralize your concern about data persistence?
Okay, it is a very clever bridge. I'll admit that. Deriving off-chain state from a deterministic standard seed phrase does solve the worst-case scenario of complete data loss. But have you read the limitations explicitly noted in the documentation for that very adapter?
I have, but I think they are just temporary growing pains.
They are massive structural hurdles for developers right now. The source material explicitly states that the wallet RGB module currently lacks RGB Lightning nodes, network configuration tools, and application-level user experience logic. It is merely an integration layer.
Right, it's a foundation.
But if I am an enterprise architect, integrating an ERC20 token on Ethereum takes my team maybe 3 hours. Integrating this RGB adapter requires me to build bespoke infrastructure to handle node discovery and off-chain data routing. Utexo essentially handed developers a high-performance engine block, but we still have to build the entire car around it. The architectural mismatch hasn't been eliminated. It has just been condensed into an adapter.
Look, you are completely right that the specific WDX adapter is a low-level integration layer rather than a full-stack, out-of-the-box node solution. But you are looking at just one tool in the toolbox. You have to look at the broader Utexo product suite.
Okay.
The adapter is for wallet developers who want maximum granular control over their infrastructure. But for the pragmatic exchange operator like yourself, Utexo offers the Utexo Cloud module.
And what exactly is the cloud module doing that the adapter isn't?
It is the fully managed control plane. It runs RGB-enabled Lightning nodes in production environments for you. It effectively removes that entire node management, liquidity balancing, and routing burden away from the enterprise.
Okay.
If you don't want to build the car, Utexo Cloud gives you the fully assembled vehicle while still preserving the cryptographic non-custodial assurances of the Bitcoin base layer. They are abstracting the friction at whatever level the developer requires.
So now we are back to relying heavily on Utexo's managed infrastructure to make this viable. And look, if it works seamlessly, enterprises will absolutely pay for that abstraction. But this brings me to another major piece of this puzzle.
Which is?
When you move transactions into completely private, encrypted client-side environments, you immediately trigger the ultimate enterprise headache: regulatory compliance. How do you prove a transaction is compliant when the transaction details are mathematically hidden from the world?
That is the beauty of their recently announced joint venture with Concordium. It completely solves the regulatory paradox you just mentioned.
Concordium, they focus on identity, right?
Yes, Concordium brings zero-knowledge proofs, or ZKPs, to the Utexo stack. And let me explain how powerful this is. A zero-knowledge proof is a cryptographic method that lets you prove something is true without revealing the underlying data. Think of it like a digital bouncer at a club.
A bouncer?
Yeah, you can mathematically prove to the bouncer that you are over 21 without ever showing them your actual ID, your birth date, or your home address.
Oh, I see. So applied to a financial transaction.
Applied to a financial transaction, a business, or even an autonomous AI agent making micropayments can cryptographically prove they have passed anti-money laundering checks or met specific jurisdictional requirements. They attach this tiny proof to the Utexo payment. The receiving institution instantly verifies the proof is mathematically valid, but the user's underlying personal data is never revealed on-chain and never exposed to the public.
That is robust.
You get the instant settlement of Lightning, the commercial privacy of RGB, and the regulatory readiness of zero-knowledge identity. Utexo is onboarding over 300 companies right now across gaming, exchanges, and payment processors precisely because this solves the compliance issue.
I have to admit, zero-knowledge proofs are unequivocally the right technical tool for that specific compliance job. Being able to programmatically verify identity without hoarding sensitive user data is basically the holy grail. But again, I am an operator, and I return to pragmatism.
Sure.
Let's look at the tower we have just built here. We are now asking an enterprise system to integrate a Bitcoin UTXO backend for security. Then we add a Lightning Network routing mechanism for speed. Then we attach an RGB off-chain state manager for privacy. And finally, we top it off with a Concordium zero-knowledge identity verification layer for compliance.
It is a comprehensive stack.
It is a staggeringly complex stack. I mean, every single one of those technologies, Bitcoin UTXOs, Lightning, RGB, and ZKPs, is notoriously difficult to work with on its own. Stacking them together, even if Utexo hides them behind a clean cloud API, introduces compounding points of failure.
I disagree that it compounds them.
The $7.5 million seed round certainly shows that smart institutional money believes Utexo can execute this vision. But when you are processing millions of transactions an hour, complexity is the absolute enemy of uptime. I see a system that will require intense, ongoing technical support just to keep from fracturing.
But the alternative is fracturing the financial system itself. Think about where we are today. We have hundreds of billions of dollars in stablecoins, digital representations of fiat currency, living completely isolated from the world's most secure decentralized settlement network, which is Bitcoin. Tether has explicitly stated they want to bring USDT back home to Bitcoin, where it originally launched way back in 2014.
Right, but it left Bitcoin because Bitcoin couldn't scale and didn't have smart contracts.
Exactly. It left for scalability and programmability. And Utexo is providing the exact infrastructure required to solve those two historical limitations without compromising Bitcoin's core security. By unifying these protocols into a single, cohesive developer experience, they aren't compounding the points of failure, they are actually resolving the fragmentation that has plagued this industry for a decade.
It's an ambitious goal.
The fact that Tether themselves, alongside massive institutional players like Franklin Templeton, led this seed round validates that the creators of the asset view this architecture as the canonical, secure path forward.
Look, Tether's financial backing is undeniable validation of the need for this solution. There is no question that the industry desperately wants native USDT running efficiently on Bitcoin. It is the largest asset on the most secure network, but wanting it and operating it reliably at scale under enterprise loads are two vastly different things. Utexo has effectively engineered a remarkable bridge over a very wide chasm.
I think it's more than just a bridge. It's a completely new highway system.
Perhaps. But my contention remains focused on the foundational ground holding up that highway. The reliance on client-side state persistence, even with clever seed phrase derivation, will cause structural and operational friction for development teams accustomed to the stateless, query-based architecture of the EVM world. The ultimate success of Utexo won't just depend on the cryptographic brilliance of their Lightning and RGB integrations. It will depend entirely on how flawlessly their WinDK modules and cloud services can abstract that profound technical complexity away from the developer.
which is a massive engineering challenge, but one they are actively shipping code to solve. To wrap up my perspective on this, Utexo provides an absolutely essential maturation of stablecoin rails. We are moving past the era of public ledgers acting as transparent surveillance networks.
Right.
By combining Bitcoin's finality, Lightning's instant execution, and RGB's privacy, Utexo offers a deterministic, bridge-free environment. Enterprises can finally operate with predictable unit costs and fully shielded business intelligence. The market is speaking, and the capital flowing into this infrastructure clearly indicates this is the path forward for native USDT.
And to summarize where I stand, the goals of eliminating dynamic gas fees and introducing true commercial privacy are vital. No enterprise wants to pay fluctuating fuel costs while exposing their cargo. However, the transition to off-chain client-side validation fundamentally disrupts established battle-tested wallet architectures.
It is a shift.
A major one. The operational burden of state persistence and off-chain routing is significant. Utexo's vision is incredible, but its viability relies incredibly heavily on their ability to abstract profound technical complexity without introducing new centralized points of failure in their routing and cloud services.
It is one of the most fascinating tensions in digital infrastructure today. Balancing true off-chain privacy with undeniable on-chain security remains a monumental engineering challenge. Analyzing these foundational protocol shifts helps us understand exactly where the financial plumbing of the internet is headed next. The evolution of Bitcoin-native financial systems absolutely warrants continued deep exploration, especially as autonomous AI agents and high-frequency trading systems begin demanding these exact types of instant private settlement rails.
I completely agree with that. The transition from globally visible public ledgers to privacy-preserving, localized state validation is a true paradigm shift. It is something every financial architect and enterprise operator needs to be watching incredibly closely, regardless of which blockchain network they currently build on.
So, to leave you with a final thought, the next time you execute a digital business transaction, ask yourself, are you operating a fragile cargo ship, paying whatever fuel price the ocean demands today, while broadcasting your cargo manifest to the entire world? Or are you ready to build a fleet with fixed costs, running on private, mathematically secure rails? The infrastructure to make that shift is arriving right now. The only question left is who will be the first to truly master navigating it.